Hi guys, this is Mr. Urrego, and today we're going to graph sine and cosine functions. Let's go. So this will be my sine function. Now the idea is to check the general equations for sine and cosine. Y equals a sine of bx minus c plus d. The same thing with cosine. As you can see, we have a bunch of letters, a, b, c, d, almost the whole alphabet. What's going on with those letters? A, which is any value that is in front of the sine and cosine, means that that's the amplitude. Okay, and whatever the amplitude is going to be the absolute value of any number that you have in there. But what is the amplitude? So the amplitude is nothing more than the distance between the x-axis and the highest value. All right, so my amplitude is 1, so my y value will be 1 and -1. So the amplitude is the distance between here and the highest, and between the x and the lowest. The highest value is called the maximum value, and the lowest will be the minimum value, and that's my amplitude. Now, B is the frequency. But what is the frequency? It's the number of cycles it completes in a given interval. Normally the interval is generally 2 pi. What are they saying? Let me translate. So the frequency is how many cycles I complete between 0 and 2 pi. Right now, a full cycle is I'm going up, I'm going down, and I come back to the x-axis. Look at this. I started there. X-axis goes up to my maximum, goes back to my minimum, x-axis. That's a full cycle. Another cycle right there. And if I keep going to the right, it will keep going cycles to the right and to the left as well. To negative infinity into positive infinity. So the frequency is how many cycles I complete between 0 and 2 pi. Right now I just complete 1, so the frequency is 1. X is my angle. And it will be given in radians, not degrees. C will tell me if my graph is moving horizontally, either to a right or to a left. D is going to be my vertical movement, up or down. Okay? And last but not least, the period of function, which is very important. 2 pi divided by b. But what's b? The frequency. Okay, so this number will be given. And that's how I find how much is the period of function. Now, we're going to graph my most basic function, which is sine of x. In our case, because there's no a here, there's no number, so you have a 1. That's my amplitude. And because there's no value in front of the x, then my frequency is 1. Okay? So from there, I'm showing you the graph right now, but from there I can find the period, which is 2 pi over b. And b is 1. Therefore, the period is 2 pi. From here to here. And then what? So I need to graph this. To graph any sine or cosine function, what's going to happen is I'm going to find 5 critical points where my graph starts, my maximum value, where it touches the x-axis again, my minimum value, and where it ends. So right there is where my graph ends, starts to end. Now, if you notice, I started at 0, 0. But how do I know what's my next value here? What I need to do, and let me show you something. I'm dividing my graph into 4 pieces. That's 1, 2, 3, and 4. Okay, so I divide my graph into 4 pieces. This is number 1, this is number 2, this is number 3, and this is number 4. And that happens with every single graph. Sine, cosine, tangent, secant, cosecant, doesn't matter which one. Once you find your period, you want to divide it into 4 pieces. So that's what I'm going to do. I'll get that and I divide it into 4. How much do I get? And that will give me, if I simplify this, that'll give me pi over 2. So what I'm getting right now is the value of my first increment, pi over 2. That's the first increment. And what I do next is I added another one, which is plus pi over 2, and that's going to give me pi. And then I add another one, plus pi over 2, and it's going to give me 3 pi over 2, plus another pi over 2, and it's going to give me 2 pi. So what I do is I find my period divided by 4. That will give me the first value. And then after that, I just add another pi over 2, another pi over 2, and another pi over 2. And that's how I get those critical points. Once I have the critical points, then I go to my graph. Or better yet, I go to my table values. 0, pi over 2, pi, 3 pi over 2, and 2 pi. I gotta find the values of y so I can graph. Okay, now remember, the x is the angle of my function. So I'm going to replace 0 here, and I'm going to find how much is sine of 0. To do this, I'm going to bring my unit circle, right? This is the angle, 0. How much is my sine? The y value. So sine of 0 is 0. Sine of pi over 2, I'm going to replace the x by pi over 2. Sine of pi over 2, 90-degree angle, right? That's pi over 2. My sine is the y value, so this is 1. Next one, sine of the next angle, which is pi. Pi is from here to here, and the y value is 0. That's my sine, so sine of pi is 0. Next, sine of 3 pi over 2, right? What I'm doing is I'm replacing the angle for the x. Sine of 3 pi over 2, 3 pi over 2, right there. I go to my order pair. The y value is the sine, -1. Last but not least, 2 pi. All the way around. That's 2 pi. This is the x, this is the y. The y value is my sine value. So sine of 2 pi equals 0. And I have my values. Now, having these values, I'm going to plot them and graph my function. I have my values now. 0, 0. When my angle is pi over 2, my y value is 1. Pi over 2, 1. Pi, 0. 3 pi over 2, -1. -1 is here. 2 pi is 0. Once I have the points, I just need to connect them with a smooth curve. Remember, my sine and cosine, they are a smooth curve. If I continue, then my graph is going to continue like that. And same thing to the left. The same thing to the left. Okay, so that's the sine function. Now, these are properties for the sine and cosine functions. Again, both are very similar. The domain is all the real numbers because remember, they go to the right and to the left. The range, -1 to 1, because that's my amplitude, right? This is the amplitude, the maximum value, and this is the minimum value. The maximum value is 1 and the minimum value is -1. Smooth curve, I just did that. Each function cycles through all the values of the range between for 2 pi, right? That's your period. The cycle repeats itself in both directions. These are properties for both. Now, this is a summary for the sine function, okay? Again, this is one cycle, the red one, and it keeps going to the right and so on and so forth. The same thing to the left. Now, let's look at the cosine function. The cosine function is the same thing, but now, according to my table of values, instead of starting here, remember my function, my sine was like this, right? That was my sine. Notice that my cosine is like moving my sine to the left a little bit. Instead of starting at 0, 0, I'm going to start, which I call the amplitude. It's going to call the amplitude. It goes to the x-axis, then it goes to the minimum, comes back to the x-axis, and it goes to the maximum. That's a full cycle of my cosine function. Okay, what happens is it repeats to the left, it repeats to the right. So it's going to look the same thing as the sine. You see that? Repeats to the left, and it repeats to the right. Comes down, and it goes up again. And infinity to the right, infinity to the left. Same idea as the cosine. I'm sorry, as the sine. But now let's find the values, because that's the whole idea. Once we have the period of the function, which is 2 pi over b, now remember, let's see, my b frequency is 1. My amplitude is 1. Okay, so let's bring that. So it's going to be 2 pi over 1, which is 2 pi. And then what I do here is I divide into 4 pieces. The reason I'm dividing this is to find out how much is my first increment. So 2 pi divided by 4 is going to be pi over 2, and that's my first increment. My second increment, you add pi over 2. The third increment plus pi over 2. The last increment plus pi over 2. You'll do this in every single function. That's how you find 0, 0, you start. This is how you find your next, your next, your next, and your next. And these are the values that you will put on your table of values. Okay? Now let's go to those values. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So let's fill out the table. So my first angle is cosine of 0. Cosine of 0 degrees is here, is the x value, which is equal to 1. Cosine of pi over 2, pi over 2 is here, equal to 0. Cosine of pi all the way up to here, this is the order pair, -1. Cosine of 3 pi over 2, 3 pi over 2, all the way here, right, 3 pi over 2, 0. And last but not least, cosine of 2 pi, which is going all the way around it, and we get back to 1. All right, so that's 1. So these are the values that I need to graph. Now let's graph them. 0, 1, 0 in x, 1 in y. Pi over 2, 0. Pi, -1. Pi, now I go -1. 3 pi over 2, 0. 3 pi over 2, 0. 2 pi and 1. 2 pi and 1. So remember, I'm coming from a curve. Curve, here's coming the other way. And then I turn back my curve. Here we go. And that's 1 period for the cosine function between 0 and 2 pi. Now this is a summary of the cosine function. Again, divided into equal pieces. This is a full cycle, but if you notice, I keep going to the right and I keep going to the left. That's why my domain is -infinity to +infinity, and my range is between -1 to 1, because this is the y values, that's my range. Okay, so let's talk about the amplitude right now. So the amplitude is the value in front of the function, okay? And there's a couple of things. Always the absolute value, that will be the amplitude. Now, if the value is greater than 1, the graph stretches vertically. If the value is between 0 and 1, it shrinks, which means it makes it flatter. And if the value is less than 0, which means is negative, then the graph is going to be reflected. Let me give an example of that. So right now, this is half of sine of x. Half. If you notice, normally my previous graph was the amplitude was 1. The only thing that changes is that it's flatter. So now my amplitude is half. I go to pi and -1/2. This one is the function that I just drew. Y equals sine of x, my amplitude is 1, right? So therefore my amplitude is 1 and -1. This red one is 2 sine of x. What is my amplitude? 2. Therefore 1 and 2, and that's the highest value, and -2 is the lowest value. But if you notice, I start here, I go to my max, I come back to the x-axis, I go to my minimum, and then I go to the end. Same points. The only thing that is changing is the amplitude. This one, what's happening? Look, it's going all the way up there. Look at the amplitude. So my amplitude here is 4, right? So let's find out the function. Y equals 4 sine of x. It goes all the way up there and up to -4. What about the blue one? So now the blue one, instead of going up, is going down to -4. That means it's a reflection over the x-axis. Therefore, instead of being +4, it is -4. If it was +4, I go up. Because it's -4, then I go down. But again, the same points. Here, minimum, x-axis, maximum, and then x-axis again. And those are the 5 critical points. Now let's graph this function, y equals sine of 2x. First things first, my first step is to find the period of the function, which is 2 pi divided by b. B is the number in front of your function, which is 2. So that's my frequency. 2 pi divided by my frequency, which is 2. In that case, the period is pi. Alright, next, I need to find the increments. So to find the increments, basically I'm looking for my table of values. Right? My first value is 0, and my next value depends on this. Whatever your period is, you're going to divide it by 4. And that's your first increment. So in this case, the period of the function is pi divided by 4 gives me pi over 4. Remember, we're looking for 5 critical points. 0, pi over 4, now I need to add plus pi over 4. The next value is always adding this increment. And the next value is adding the increment. And the next value is adding the increment. That's how I find those points. So this point, my second point, will be this plus pi over 4, which is 2 pi over 4. If I reduce this, it's going to give me pi over 2. But let's not reduce it. Let's see how it goes. My next value is plus pi over 4. So 2 pi over 4 plus my increment, which is pi over 4, that gives me 3 pi over 4. And my last increment is that plus pi over 4, and I hope you're getting the idea that every time I'm adding the same increment, this same value that I got in the beginning. That's going to give me 4 pi over 4, which is pi. Alright? We'll decide in a minute if I'm going to reduce it or not. Once I have this, what I need to do is replace it in the original function. So let me bring the original function, and I'm going to replace those values. So my first value is 0. So it's 2 times 0, which is 0. So sine of 0, according to my unit circle, remember, you have to bring that. You have to remember your unit circle. Okay, this value is 1, 0. Pi over 2 is going to give you 0, 1. Pi is going to give you negative 1, 0. And 3 pi over 2 is going to give you 0, negative 1. Keep that in mind. Okay, so sine of 0 is 0. Then the next value is with pi over 4. Now I bring pi over 4. If you notice, I replaced the x by pi over 4. Now 2 times pi over 4 is going to give you pi over 2 because you reduce that. And sine of pi over 2, this is pi over 2. Sine, it gives me 1. Next, same idea. Same angle, the next angle is 2 pi over 4. Alright, plug it in. Simplify. So if you notice, I simplified 2 times 2 is 4 divided by 4, and that gives me pi. Sine of pi is 0. Next value, let's plug in the 3 pi over 4. 3 pi over 4. Simplify this, is going to give me 3 pi over 2. 3 pi over 2 is right here, and my sign is negative 1. My answer is negative 1. Last but not least, 4 pi over 4. Okay? But 4 pi over 4 is the same as pi, so let's bring pi over here. 2 times pi is 2 pi, and my circle, I'm going all the way around it. My sign is 0 again. So that's how I find those points. Once I have those points, I need to graph those values. Okay, so pi over 4, 2 pi over 4, 3 pi over 4. Okay, so if this is pi over 2, then over here is going to be pi over 4. And this is going to be halfway, is 3 pi over 4. Okay, so remember the previous pi. That means I'm going to have 2 cycles between 0 and 2 pi. Now, the amplitude is, let me see, is y. Okay, excellent. So my function, my amplitude is 1. So let's do that. Let's call this 1 for example. And 1, 2, 3 is going to be negative 1. So my table values, my first value is 0, 0. And then I go to my maximum value. My first value is 0, 0. My next value is pi over 4 and 1. And the next value is pi over 2, 0. And then my next value is 3 pi over 4, negative 1. And my next value is pi, 0. Once I have those points, I just need to connect them with the curve. Curve, curve, curve. Okay. So you notice, let's go back to the frequency. The frequency is how many of this I have between 0 and 2 pi. Technically, I can draw another cycle of those. So from here, it goes to my maximum. Then I go back to the intercept. Then I go back to my minimum. And then I go back to the x-intercept. So that's that cycle. I start, maximum value, x-intercept, minimum value. And this is horrible because this should be a curve. There you go, curve. And that's the cycle. If I'm going to start again, maximum, x-intercept, minimum, x-intercept. And it keeps going and going to the right and to the left. Okay? Let's practice another example. Now let's graph this one. 2 pi over b. Remember, you got to find the period of the function. 2 pi divided by, now, this is 1/2. Okay? 2 pi divided by 1/2 gives you 4 pi. So now the period became bigger than 2 pi. And it did that because this is a fraction. Be aware of that. Now let's find the increments. The increments, I take the period and I divide by 4. In this case is 4 pi over 4, which gives you pi. Now each increment is equal to pi. Let's do that. 1, 2, 3, 4, and 5. First one is 0. Next increment is pi. Plus another pi gives you 2 pi, plus another pi gives you 3 pi, plus another pi gives you 4 pi. Remember, each increment you add pi. 1, 2, 3, 4, 5. Those are the 5 critical points. You go back and you plug it back in. Now you have a minus in front of the function. That means there's going to be a reflection over the x-axis. Let's plug it back in. So y equals negative sine of x over 2. If x is 0, then I have negative sine of 0, and sine of 0 is 0, therefore gives you a 0. Okay, so let's use this as help. Alright, I brought this unit circle again. Those are the coordinates for 0, pi over 2, 3 pi over 2, and 0, pi over 2, pi, and 3 pi over 2. Now, my next value is pi. Instead of the x, I put a pi. But remember, I have a 2 dividing, so it's pi over 2. Pi over 2 gives me 1. That's sine. So that's going to give me negative 1. Now, what about plugging 2 pi now, right? Instead of 2 pi, that's my next value. That's going to give me 2 pi divided by 2 is going to give me negative sine of pi. And pi is all the way here, and the sign is 0. Therefore, it's going to be negative 0. What about 3 pi? Now it's going to give me 3 pi over 2, and 3 pi over 2 is all the way here to 70, and my sign is negative 1. So I have negative, and sine of 3 pi over 2 is negative 1 becomes positive 1. The last one is going to be 4 pi. If I simplify this, it's going to give me negative sine of 2 pi, and 2 pi is going all the way around it. Therefore, my sign is 0, and now I'm going to have negative sine of 0, which is 0. Alright, so these are the values. Let's plug this into the graph. Now it's in terms of pi, so it's going to be pi, 2 pi, 3 pi, 4 pi. So we're going to be using these values. Okay, so it's going to be pi, 2 pi, 3 pi, 4 pi. You notice my graph gets stretched big time. Now, the amplitude is the same, but in my case, it's going to be negative 1. Alright, so instead of my graph going up, it's going to come down. So 1, 2, 3, this is 1, 1, 2, 3, this is negative 1. Alright, let's look at the table of values. 0, 0, pi, negative 1. 0, 0, and then pi is going to be negative 1. You notice instead of going up, now I'm going to be going down because it has a negative in front of the function. The next value is 2 pi 0. 2 pi 0, 3 pi 1, and 4 pi 0. 3 pi is 1, and 4 pi is 0 again. So it starts from here, it goes down, goes up, and goes to the intercept. So those are my 5 critical points. Always where I start. If it's negative, then I go to a minimum, then I go back to the x-axis, then I go to a maximum, and then I go back to the x-axis. Alright, let's graph with red, let's graph y sine of x, your basic function, because you will be asked to compare it to the basic function. Remember, the period here was 2 pi, and my increments was this divided by 4, which is pi over 2, right? So now, I'm not going from 0 to 4 pi, I was going from here to 2 pi. That's the whole cycle. And then pi over 2, so if you remember, I go to my maximum. I start at the origin, go to my maximum, go back to the x-axis, go down to the minimum, and go back to the x-axis. So this is your basic function. You're going to divide the period into 4 pieces, and if this is positive, then you go up in the first piece, you go back to the x-intercept, you go to your minimum, and you ended up in your x-axis. If I'm going to do another cycle, it will be the same thing. Now, from here to here is pi over 2, so I go to my maximum, I go back to x-axis, I go down to my minimum, and then I ended up with my x-axis. This is another period of my basic function. So you see that I have 2 cycles instead of 1. So when you have a fraction, that will stretch your graph. In the other hand, we graph sine of 2x. And the period for this was 2 pi divided by 2, which is pi. And the period with that was pi. Meaning, I was going to graph the full graph between here and here. Right? If you remember, it was pi over 4, then pi over 2, and then 3 pi over 4, and then pi. And then, where do I start? Here. It's positive, so I go up. My first increment, I go up. Then I come down to the x-axis. Then I go down to the minimum, and then I come back to the x-axis. So this was my graph. And the reason I'm doing all these graphs in the same coordinate plane is you see the difference. You see the difference. This one gets more stretched vertically, right? This is my original function, and now this is divided by 1/2. Okay, that's it for today. Next one is going to be shifting vertically and horizontally. Okay? Alright guys, make sure you subscribe to the channel, like the video if you're learning, please. And thank you for watching. I'll see you in the next one. Take care. Bye-bye.